Like I said, everybody's on the list, and why I don't use a phone. Very rarely put it together for an interview, for an emergency. Or make a quick call or a text message if I've got credit on it. But otherwise, it sits at the other end of the house, pulled apart, inside a filing cabinet like a Faraday cage.
Scratch. Now, Mark dropped a... This runs a long-range radio, 915 megahertz, no Wi-Fi. This runs on Wi-Fi, no long-range radio. Different frequencies, different hardware. They have absolutely no way to talk to each other, except they just did. And that shouldn't be possible because these two devices don't share the same modulation technique, the same radio hardware, or even the same frequencies. And they definitely shouldn't understand each other unless what we think of as the internet isn't actually cables or towers, it's just routing. And once you realize that, some very strange things become possible. And by the end of this video, I'm going to show you where this is all heading with one of the strangest rigs I've ever constructed. I'm still shocked that it actually worked. But first, you need to understand what made that possible. Over the past few years, covering decentralized radio tech, building nodes, breaking things, and testing systems that most people never even see, I kept seeing the same name come up over and over. In the comments, in forums, in my DMs, a project I'd mostly ignored, Reticulum. Some people have started calling it the Hacker Network, not because it's illegal, but because it represents a completely different philosophy about how communication should work. Open, autonomous, sovereign communication that doesn't rely on permission or centralized infrastructure. And instead of just talking about it, I decided to build one to see if the idea actually holds up in the real world. But why do we need something like this at all? The problem is, today our devices are very capable, diverse, and ever-changing. But despite that, when we attempt to communicate, our data must flow through remote infrastructure run by other people. So if I want to send a message to Amelia, she's literally downstairs in the same house, something strange happens. That message doesn't just go from my device to hers. Instead, the packet leaves our home network, travels out to remote infrastructure run by companies we don't control, possibly hops across multiple data centers, sometimes across state lines, sometimes across countries, passes through a chain of intermediaries, and only then does it come all the way back into the house to reach her phone. Two devices just a few feet apart. And to me, that just feels wrong. Most of our communication today is controlled by the communication cartels, which are centralized platforms and infrastructure that sit between us and decide how, when, and sometimes if we can talk. They effectively control our action potential in the digital world. They can shut us off intentionally, as we've seen in real-world crises where communication channels suddenly disappear, or accidentally, like the Verizon outage last month that left millions without service. Now, I'll be honest, when I first looked at Reticulum, I wasn't sold. I mean, the ideas are beautiful, but I've seen a lot of beautiful ideas die in a GitHub repo. So I went deep. I read the docs, I watched Mark's Unstoppable Networks talk at Chaos Communication Congress, looked at real deployments, FryFunk, Mesh NYC, GiphyNet, Meshtastic communities, and the deeper I went, the more confused I got because the philosophy made sense, but I still couldn't answer one simple question. Does anyone actually use this? Or is it just another beautiful idea? I decided to stop wondering and just build the thing and see if we could put together our own parallel network. So I started with an R node, a full build from scratch. Now, Mark dropped a guide on his personal blog, unsigned.io, that walks you through the broad strokes. This build uses a T-Beam LoRa board, an Adafruit NeoPixel, a small OLED display, and a very serious-looking inspired military antenna. The case is 3D printed, and everything runs on open-source software. This particular build will sport a LoRa radio so that I can bring it into the mountains with me, and I mostly use gear that I already had lying around, but I did have to grab a few small parts from Adafruit. And if you want to follow along, I put together a complete builder guide on my website because, full transparency, I hit a few walls. Now, before we go any further, I want to address the obvious question. If you've used Meshtastic or MeshCore, this might look familiar. Same LoRa hardware, similar form factor, so what's the difference? Meshtastic is an incredible project. It treats the radio as the network. Every device talks to nearby devices, messages hop node to node, and everything revolves around that single LoRa transport layer. For lightweight messaging and telemetry, it's hard to beat. Reticulum does something fundamentally different though, because it's not a radio protocol, it's a full networking stack. So radios, Wi-Fi, Ethernet, serial cables. Reticulum treats all these as interchangeable interfaces, which means you can talk to people who don't have the same hardware as you, because the network lives above the hardware, which means a single Reticulum network can span a incredibly slow 5-bit per second Morse code key on one end and a fiber optic line on the other. The spec has no physical upper bound in terms of bandwidth, and the protocol is smart about it. It discovers routes, measures link quality, and knows to send large transfers over fast links, not slow ones. A packet doesn't replicate endlessly across every node, instead it follows an established route. So at a high number of hops, overhead scales linearly and not exponentially. That's the core difference. Meshtastic builds a mesh of radios on the same frequency and configuration. Reticulum builds a network that can use radios but isn't limited by them. The other thing that sets it apart is identity. There are no usernames, no phone numbers, no IP addresses. Every device generates its own cryptographic identity, and your address on the network is derived from that identity. Encryption isn't bolted on after the fact, it's the foundation. All traffic is encrypted by default, and the origin of messages is obscured by design. Think of it less like traditional networking and more like how Web3 treats cryptography as a base layer that everything else is built on. And you don't need an R node to try this. You can run Reticulum over Wi-Fi with an app like MeshChat, or bridge multiple interface types at the same time. Alright, so the R node is built. Now we just need to bring it to life. If you're using a stock supported board, you can flash the firmware straight from a web flasher similar to Meshtastic, but because of this custom build, I needed to modify a few things. I used my IDE to tweak the code, compile a build, and flash it to the device. Now, one R node is interesting, but to actually prove what we talked about, we need a pair. So I'm also going to flash a bare LoRa32 v3, which, if it looks familiar, that's because it was running Meshtastic about an hour ago. Same hardware, completely different network. For the client side, there are a few options. You have apps like Sideband, Nomad.net, but the one I had the most luck with is a desktop app called MeshChat. So that's what we'll use. So let's start simple. Two devices, both on Wi-Fi. Reticulum discovers the path automatically and messages go through. Nothing exotic yet, but watch the network visualizer. You can actually see the route forming in real time. Now let's swap to something more interesting. Same message, but now it's traveling over 915 megahertz LoRa. No Wi-Fi, no internet, no infrastructure at all. Just two radios and open spectrum. Now the one I've been waiting for. This is what I teased at the top of the video. One device on LoRa, one device on Wi-Fi. So on my phone here, I have Sideband going. Sideband spins up its own local instance of Reticulum on this device. This device is connected to the network over Wi-Fi. It doesn't have any LoRa radio or anything like that. It's just connected over the Wi-Fi interface. The other node is a standard R node. This is using a T-beam, and it's only using LoRa as the Reticulum interface. And then the client is MeshChat on my computer here, and I have a conversation going between these two devices, between the two clients, and so I can...
So basically, when your text messages, dick pics, nipple flicks, emails, phone calls are all being intercepted in real time, But I don't know. The two cops at the library sitting there talking to each other on identical laptops, pretending to study in a building full of computers that aren't being used. Well, I'm not trying to hoodwink these guys, right? You're quite capable of doing that yourselves. You're doing damage control. I just want to tell the truth. I'm not the one with something to hide. I just about need my privacy.